Good day everyone! Welcome to our virtual instruction for week 9 and 10 of quarter 2 Mathematics 10. Our competency is graphs and solves problems involving circles and other geometric figures on the coordinate plane. The instructional material is prepared by Ma'am Medea C. Catalan of UCNHS and to be discussed by yours truly, Ma'am Pearl Mizrak G. Barongan of UCNHS. Since we already know how to find the general equation and standard form of a circle, we will now graph the equations of a circle. Here are the points to remember in graphing a circle. Here are the steps on how to graph a circle on the Cartesian plane. Step 1. Determine the center HK of the circle. Step 2. Calculate the radius by solving for r. Step 3. Plot the radius points on the coordinate plane. Step 4. You count r units in every direction from the center HK, left, right, up, and down. And lastly, connect the dots to graph the circle using a smooth, round curve. The simplest circle to graph has its center at the origin, or point 0, 0. Because both h and k are 0, they can disappear and you can simplify the standard circle equation to look like x squared plus y squared is equal to r squared. For instance, to graph the circle with equation x squared plus y squared is equal to 16, you must follow these steps. First, get the center of the circle. Since there is no HK in the equation of the circle, its center is the origin. So we have the center 0, 0. Since the value of r squared is equal to 16, you will get the square root of 16 to get the value of r, which is 4. For your activity 1 in your activity sheets, the direction, determine the center and radius of the circle, then graph it in Cartesian plane. Use a graphing paper to do this activity. Number 1. X squared plus y squared plus 4x is equal to 0. First, we must regroup the terms with respect to the similar variable x. We must look for the value that will give us a perfect square trinomial for the variable x. So, we have x squared plus 4x plus 4 plus y squared is equal to 0 plus 4. We added 4 to the both sides of the equation. Next, by factoring the perfect square trinomial, we have x plus 2 squared plus y squared is equal to 4. So the value of x is equal to negative 2, and the value of y is equal to 0, and for our r, we have the value of 2 from the square root of 4, which is 2. So, the center of the given circle is equal to negative 2, 0, and the radius is 2. So here is the graph of the given circle. We have its center at negative 2, 0 and a radius of 2 units. Number 2. A circle with equation x squared plus y squared plus 2x minus 6y minus 39 is equal to 0. Again, we must regroup the similar terms with similar variables. First, we have quantity x squared plus 2x for the x variable and y squared minus 6y for the y variable is equal to 0. Now, we must complete the following perfect square trinomial. So, for the variable x, we will add the constant 1, and for the variable y, we will add the constant 9. Since we added 1 plus 9 in the left side of the equation, we must also add 1 plus 9 on the right side of the equation. By factoring the perfect square trinomial, we have x plus 1 squared plus y minus 3 squared is equal to 49. So, the value of x is equal to negative 1 and the value of y is equal to positive 3 and the radius is equal to 7. 7 is the square root of 49. So, the center of the given circle is equal to negative 1, 3 and a radius of 7 units. So, here is the graph of the circle. We have the center at point negative 1, 3 and a radius of 7 units. Number 3. X squared plus y squared minus 10y is equal to 0. Again, regroup the following with respect to the similar variable x and y. So we have x squared plus quantity y squared minus 10y is equal to 0. So we have to complete the trinomial square for the variable y. So we must add 25 to the left side and the right side of the equation. Now, by getting the factor of the perfect square trinomial, we have x squared plus y minus 5 squared is equal to 25. We now have the value of x, which is equal to 0, and y equal to positive 5 and a radius of 5 units. So the center of this circle is at point 0.05 and a radius of 5 units. Here is the graph of the circle. We have the center at point 0.05 and a radius of 5 units. For number 4, we have x plus 1 squared plus y minus 4 squared is equal to 36. Since we already have a perfect square trinomial, we just now have to express the value 36 to the form r squared. So, the square root of 36 is 6. So, we now have the value of the radius r equal to 6. So, the value of x is equal to negative 1 and the value of y is equal to positive 4. The center of this circle is equal to negative 1, 4 and radius of 6 units. This is the graph of the given circle. We have the center at point negative 1, 4 and a radius of 6 units. Examples on Activity 2. Direction. Solve for what is being asked in the following problems. Number 1. What is the equation of the circle with a radius of 5 if the line x equal to 3 is tangent to it at point 3, negative 2? So, in here, there are two possible circles. So, based from the tangent line x equal to 3, we will count 5 units to the left and 5 units to the right. So, we form two circles. We have the blue circle for our circle 1 and red circle for our circle 2. So, the center of our circle 1, by counting 5 units from x equal to 3, so we have negative 2 and negative 2. And the center for our circle 2 is positive 8, negative 2, counting 5 units from x equal to 3. So the solution, we have to substitute the coordinate of the circle 1 in the standard form of the equation of a circle. So the standard form of the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. Since the center of our circle 1 is at point -2, -2, so the value of h is equal to -2 and the value of k is equal to -2. So, by evaluating the equation, we now have x plus 2 squared plus y plus 2 squared is equal to 25. For our equation 2, we will also substitute the value of the center of our circle 2. And the center of our circle 2 is 8, -2. So the value of h is 8 and the value of k is -2. By evaluating the formula, we have x minus 8 squared plus y plus 2 squared is equal to 25. So, these are the equation of the two circles tangent to the point -3, 2. Number 2. Find the area and circumference of a circle whose equation is x plus 4 squared plus y minus 3 squared is equal to 49. Remember that the area of a circle is equal to pi r squared and the circumference of a circle is equal to 2 pi r. So, our solution, we have r squared is equal to 49, so our r is equal to the square root of 49. R is equal to 7. So, the area of the circle is equal to pi r squared. Substituting the value of r, which is 7, we have pi multiplied by 7 squared. So we have 49 pi for the area of the circle. The circumference of the circle is equal to 2 pi r. By substituting r by 7, we have 2 pi multiplied by 7, so we have 14 pi. Number 3. Write the equation of the circle whose area is 16 pi and whose center is at -3, 2. So the solution, we have the area of the circle as pi r squared. So the given area is equal to 16 pi. By equating the two equations, we have 16 pi equal to pi r squared. Dividing both sides by pi, so we have 16 is equal to r squared. So our r is equal to the square root of 16. So, by substituting the equation of the circle by hk, we have our h -3 and k equal to 2. The equation of the circle is x plus 3 squared plus y minus 2 squared is equal to 16. Here is a sample for your activity 3. So, a group of students are playing a certain game wherein each of them have a certain circular area to guard. A student is eliminated when a ball touches the ground of his or her circular area. To accurately play this, their teacher draws a Cartesian plane on the ground. Mark is a student in the class and he is assigned to point 38. If their circular area is determined by considering their assigned coordinates as the center of their circle, which have a radius of 5 units long, what is the general equation of the circle that encloses the area covered by Mark? So the given in this problem are the center at point 38 and the radius of 5 units. So for our solution, we have first the standard form of a circle. The standard form of a circle is x minus h squared plus y minus k squared is equal to r squared. We will substitute the value of hk, which is the center 3, 8, and r 5 units. So we have x minus 3 squared plus y minus 8 squared is equal to 25, the standard form of the equation of the circle. But the problem is asking for the general equation of the circle. So in order to find the general equation of a circle, we have to expand the standard formula. So x minus 3 squared is expanded and y minus 8 squared is expanded by using the FOIL method. So, by multiplying x minus 3 by x minus 3, we have x squared minus 6x plus y, and y squared minus 16y plus 64 is equal to 25. Now, we must group them according to their respective variable. So, we have x squared minus x plus y squared minus 16y, and all the constant must be added. Now, we have x squared minus y squared plus 6x minus 16y minus 48 is equal to 0, our general equation of the circle. So that's it for our week 9 and 10 of quarter 2 Mathematics 10. Thank you and stay tuned for the next virtual instruction.